Hi, my name is Agustin Contreras, and today I'm going to be showing you how to do a gel electrophoresis. Gel electrophoresis is a method for separation and analysis of proteins and their fragments. It is used in clinical chemistry to separate proteins by charge and/or size and serves a multiple of uses in fields such as biochemistry, molecular biology, and in this case, pathology. How is SDS used in gel electrophoresis? How is this detergent used in this technique, is what my question is.
You will need molecular water, 1.5 molars of Tri's buffer, pH of 6.8, 20% SDS, acrylamide/bisacrylamide 30% or 0.8% weight over volume, 10% APS, and last but not least TMED. In this part of creating the gel, I will be showing you the measurements I used to create my resolving gel. The following measurements are to be exact and not to be over the limit. This can cause issues with accuracy if not handled properly. For my stacking gel, I used similar ingredients as I used in my polymerizing gel while making one change to my acidic level of my tri-HCl pH of 8.8 to instead 6.8. I used 4.62 milliliters of molecular water, 1.875 milliliters of pH of 6.8 tri-HCl. I also used 0.0375 milliliters of 20% SDS. I used 1.005 milliliters of acrylamide/bisacrylamide 30% or 0.8. I also used 0.0375 milliliters of 10% APS. And last but not least, I also used 0.007 milliliters of TMED. Gently pry off the green plastic knife away from the gel plate. In this small clip, the gels are being loaded onto the gel plate, which will then be loaded onto the gel chamber and then be hooked on to a power supply to then start the running of the gels. This is done to prepare the gels so that when the samples are being loaded, no problems will occur. After my gel has been running, I will then load on my samples. I will first start with putting my protein ladders on the edges of the wells in order for me to be more organized. Then I will put my proteins of interest in the middle. Here you can see that SDS, or sodium dodecyl sulfate, a detergent, denatured the proteins and gave them a uniform charge, which allows the proteins to move freely within the gel. That helps because heavier proteins will stay at the top while the smaller proteins will be able to float down to the bottom. Which leads to my next question: what else can gel electrophoresis be used for? And using a green plastic knife, pry off one of the glasses from the gel plate. Make sure to be very careful when proceeding to this step, and make sure your gel is in perfect condition. Again, using the green plastic knife, you will cut off the stacking gel portion or the top portion of the gel and remove any residue that was left, only to have the primary polymerization gel. Then slowly and carefully scoop up the gel from the bottom and make sure that none of it is damaged. This is but a small part of what I have to show of what I learned in science. There are more things to be learned, and there are more questions to be asked. I'd like to give credit to the following people who helped make this video possible. Also, I'd like to give credit to the original owners of the following clips that I was using in my video. I see a world with innovation and breakthroughs. So let me ask you this: what kind of world do you see in science?